Good morning, friends. I'm Suneeta Phadkule, professor in mechanical engineering, working at JSPM's Jaywantrao Sawant College of Engineering, Hadapsar, Pune. This is our video lecture number 35, which is based on unit number 4, that is on balancing. So today we are going to see the numericals on balancing of multi-cylinder inline engine, part 2. Already in part 1, we have solved 2 numericals. Now in this one, we are going to solve 2 more numericals. Learning outcome is you will be able to estimate unbalance of multi-cylinder inline engine and how to balance it. Okay. So this is the syllabus content. Here we are balancing in multi-cylinder inline engines. Now let us see the recap. What we have learned in theory in unbalance. Specifically in reciprocating unbalance, we have seen that unbalanced force is given by 2 components, primary force and secondary force. Okay, so primary force maximum magnitude is mr omega square and secondary force maximum magnitude is mr omega square upon n, and we are always interested to find out the maximum force. Okay, so this is the comparison between primary and secondary crank. When we'll solve the problem, first we have to draw primary crank diagram and secondary crank diagram. So we have to show the notation like this. Mass is m, radius, crank radius is r, for secondary r upon 4n, angular velocity omega for primary crank, 2 omega for secondary crank, and angle between 2 crank is, if it is phi for primary crank, it is 2 phi for secondary crank. Now let us read the statement, problem statement. A 6-cylinder 4-stroke vertical engine has a firing order 145236. Firing takes place with equal angular interval. The mass of reciprocating parts per cylinder is 2 kg. Stroke 100 mm and connecting rod length is 200 mm. The cylinder center lines are spaced at 300 mm apart. The crankshaft speed is 300 rpm. Examine the engine for the balance of primary and secondary forces and couples. If the engine is not completely balanced, suggest a suitable firing order to make it completely balanced. Okay, so this is the given data. Firing order is given, that is 145236. Okay, then mass of each cylinder is given 2 kg. Stroke is given 100 mm. Therefore, we can find out radius of the crank, that is stroke by 2. So it is 0.05 meter. Then length of the connecting rod is given 0.2 meter. So we can find out n, that is obliquity ratio L upon R. So that is equal to 200 upon 50, that is 4. Then speed is given, shaft speed, that is 300 rpm. Find out omega. Okay, so that is 31.41 radian per second. Now angle between the 2 cranks. Okay, so see here it is given 4-stroke engine. So how to find out the angle for 4-stroke 6-cylinder engine? As it is a 4-stroke, angle should be 720 degree to find out the angle between 2 cranks. So 720 divided by 6, that is 120 degree is the angle between the 2 cranks. And we have to find out primary unbalanced force and secondary unbalanced force. If it is any unbalanced force is there, then primary couple and secondary couple which is having the unbalance. Okay, so this is your configuration diagram. Okay, cylinder number 1, 2, 3, 4, 5, 6. Okay, so this is along the length of the shaft. Then there all distances are given. Every cylinder is 0.3 meter apart. Okay, now where to take reference plane? For reciprocating engine problems, we have to always take reference plane to maintain the symmetry. Okay, so that means in the middle of the shaft. So it is, we have to choose the reference plane between cylinder number 3 and 4 so that symmetry will be maintained. Okay, now let us draw the let us write down the table. Okay, so what is this normal table? All columns are same. As I told you, in every problem these columns are same. Okay, so let us write down first column, that is plane. As there are 6 cylinders, there will be 6 planes we have to consider. Then mass of each cylinder is 2 kg. Okay, for all 6 cylinder. Radius of the crank radius of the cylinder is 0.05 meter. So that is also same. Then centrifugal force, naturally it will also be same. So it is proportional to M into R. So this column will give you centrifugal force. Okay, so that is 0.1 Newton for all 6 cylinder. Okay, now here in this column you have to write down distance of each plane from the reference plane. Where is your reference plane? Between cylinder number 3 and 4. Okay, so let us write down the distances. What are the distances? See here, from reference plane, cylinder number 1 plane is at a distance 0.3 plus 0.3 plus 0.15. Okay, here it is given, it is 0.75. Okay, cylinder number 2 0.45, cylinder number 3 0.15. Similarly for right hand side, 0.15, that is for cylinder number 4, for cylinder number 5 0.45, cylinder number 6 0.75. But the cylinders which are falling on the left hand side, we treat it as a negative couple. Okay, because if these are giving anti-clockwise couple, this will be providing clockwise couple. So the cylinders or couples which are falling on the left hand side, we will give negative sign. So minus 0.75, minus, minus. Then for right hand side cylinders, that is positive. Okay, now this is very important. Okay, here you have to write down angle according to this firing order. Again, I am telling you, though you have written these planes in the sequence 1, 2, 3, 4, 5, 6, we have to write down primary crank angle. That means the angle between each two crank for primary, it is 1, 4, 5, 2, 3, 6. This sequence you have to follow to write down the angle between each two crank. Okay, so first is cylinder number 1 plane. So we have to assume it is 0. Some reference we have to take. So always for first cylinder, we have to assume 0 degree angle. It may be along the positive x-axis, it may be along the positive y-axis. Anything you can assume. Okay, so this is 0 degree. Then for cylinder number 4, what's the angle between two cranks? Here we have written it is 120 degree. Okay, so after 1 it is 4. So as cylinder plane 1 is 0 degree, plane 4 is 120 degree. Okay, then plane number 5, it is 120 plus 120, 240. So cylinder number 5, 240. Okay, then cylinder number 2, 240 plus 120, 360. Okay, then cylinder number 3, 360 plus 120, 480. Okay, so 480 minus 360, it is basically 120 angle. Okay, then cylinder number 6, what is the angle? 480 plus 120, that is 600. Okay, 600 minus 360, 240. Understood how this angle have been written? These are written in this sequence, that is a firing order, and angle between each two crank in this sequence is, you go on adding 120, 120, 120 like this. Okay, now you have to write down the last column, that is secondary crank angle. Okay, so again, what is the angle? Now see, you have already seen this table, that's why I purposely kept this. The angle between two cranks, for primary crank if it is phi, for secondary crank it is 2 phi, double. Okay, so this column is very easy to write down. Just make a double angle, double of this one. Very easy, don't think at all. 0 into 2, 0. 360 into 2, 720. Okay, so 720 means, you know, 720 minus 360 minus 360. Okay, it is 0 degree. Okay, then 480 into 2, 960. 960 minus 720, it is 240. Or you can make 120 into 2, that is 240. Okay, 120 into 2, 240. 240 into 2, 480 minus 360, 120. Okay, then 600 into 2, 1200. Minus 720 minus 360 will give you 120. Understood? So again, I will explain you secondary column angle. Okay, this crank angle, just make it double, nothing else. Okay, so now you have to draw primary crank diagram and secondary crank diagram based on this column. This is primary. You have to refer these angles to draw plane number 1, 2, 3, 4, 5, 6 mass, and this column, that is secondary crank angle, to show planes 1 to 6. Okay, so here it is. So based on column number theta p, primary angle, theta s, secondary angle, you have to draw the angle, primary crank diagram and secondary crank diagram. Okay, so let us see here for primary crank diagram. Here for primary crank diagram, for plane number 1, angle is 0 degree. Okay, and plane number 2, 360. Okay, so see here. Plane number 1, 0 degree. Here I have taken reference, vertical. You can take horizontal also. In few book they have taken positive x-axis. Even for our rotary problems, rotary unbalanced problems, we have considered positive x-axis as a 0 degree, that is reference. But here in reciprocating, we have considered positive y-axis is a reference plane. Okay, so first angle, first mass is falling on the here 0 degree. Second is 360. It came here only. Okay, then cylinder number 3 and 4. See, this is 120, this is 120. So cylinder number from 1, it is 120 degree angle. Cylinder number 3 and 4, both are at one place. Then cylinder number 5 and 6, 240, 240. Okay, so from here it is 240, 5 number, 240, 6 number. Okay, then draw this secondary crank diagram. Let us see. Crank number 1, say plane number 1 and 2. Where is the unbalanced mass? 0 degree, 0 degree. Okay, so see here 1 and 2 at 0 degree. Okay, then 3 and 4. See, this is 240, 240. Okay, both are at same place. So from 1 it is 240 and 240. Cylinder number 3 and 4. Okay, then 5 and 6, 120, 120. So here 120, from here it is 120, 5 and 6. Okay, so what's the change here? This is the 1, 2, 3, 4, 5, 6, and here it is 1, 2, 5, 6, 3, 4. Okay, see, this is you have to consider in this direction only. Why in this direction? To show the angular position, because your omega you have assumed in this direction. Okay, you can assume other opposite also, no problem. But here we have assumed anti-clockwise rotation of the crank. Understood? Now further thing is very easy. Just you have to draw parallel lines to these planes to show the unbalanced forces or couples. Okay, so let us draw the force polygon first. Okay, as you have to draw the vector diagram, you must know what is the magnitude, you must know what is the direction. Okay, now let us find out the magnitude. Already we have found out Fp is proportional to m into r. Omega square we are not considered because that was same for all the one. And here it is reciprocating engine. M is also same, r is also same. Okay, so what will be your magnitude of primary force? M into r, 0.1 Newton. See, already we have written here. Here it is 0.1 Newton for every cylinder, every plane. Okay, so this is the primary force. Now, what's the secondary force magnitude? You know, it is mr omega square upon n. Omega square we are not considered, simply mr upon n, but n is also same, m is also same, r is also same. So just 0.1 divided by n will give you 0.025. So for all cylinders or all planes, secondary force is 0.025 Newton. Okay, so as for all cylinder, primary force is same. Let us draw the primary force diagram by taking suitable scale. Okay, every force is having the same length, every vector is having the same length, only the direction is different. Okay, so starting here, this is your initial point, that is pole. Okay, now let us see cylinder number 1, cylinder number 2. Okay, both are in the same direction. So this is your 0.1 Newton, this is our 0.1 Newton, and both are in the vertically upward direction because this is our primary crank diagram. 1. See, in force polygon there is no positive negative. Every force is positive because it is acting outward. Okay, so you have to always imagine the forces outward, in the outward direction. So 1 and 2 are upward, that we have drawn here. Now 3 and 4 in this direction, both. Okay, so draw here. We are here now. So from 2 to 3.1 Newton, 3 to 4.1 Newton. Okay, then 4 to 5, 5 to 6. As you know, this is the direction, 5, 6. Okay, now what scale we have taken? We have taken certain scale. Suppose 1 centimeter is equal to 0.1 Newton. Then this line is 1 centimeter, 1 centimeter, like this. Okay, so you will get a close triangle. That is a close polygon. That is a triangle, symmetrical triangle. Okay, so this is a primary force polygon. Similarly, you can draw secondary force polygon. Here it is a 0 point. So starting from 1, then 2, then 5, 6, 3, 4. So starting point and initial point is same. So you are getting close polygon. That is a symmetrical triangle. Okay. So what is the meaning of this one? Both the primary and secondary forces are completely balanced. Okay. And already we have seen from this table only. Okay. You can imagine from this crank diagram only, just by observation, you can tell that primary and secondary forces are completely balanced. Okay. But without drawing couple polygon, you cannot conclude like this about the couples, whether those are balanced or not. Okay. Now let us draw the couple polygon. Now see, what is the magnitude of the couple? See here. So there are 6 couples. Okay. 3 are negative, 3 are positive. Okay. And again, I will tell you, you can follow any sequence to draw the polygon. Okay. So let us see here. Now couple polygon. Okay. So this direction theta p and theta s. Okay, but don't see the column. Once you have drawn primary and secondary diagram, crank diagram, no need to refer theta p and theta s column. Okay, only you have to refer primary crank diagram and secondary crank diagram. Okay, so let us draw this one now. Okay, primary couple polygon. So take suitable scale. Now we are here now. Okay, initial point or pole. Now here we have drawn for couple unbalanced or couple for plane number 1, say downward, and after that say plane number 2, that is also downward. Why downward now? Now see 0 to 1, what is the magnitude, and 1 to 2, what is the magnitude? Go to this table. These two are negative couple. That means what? Negative couple means it is the opposite direction of the force. So cylinder number 1 and 2, magnitude is 0.075 and 0.045. What are the directions? See here. Force was upward, that is positive, but couple is negative. So upward direction is positive. So negative direction is downward. That's why we have drawn 1 downward, after that 2 also downward. Okay, and taking this magnitude, taking suitable scale. Okay. Now, what we have drawn after that? See, we are here. We have drawn 0 to 1 downward, 1 to 2 downward. Okay. Now, you can draw 3, 4. Okay. See, 3 is in this direction because it is negative, and 4 is positive, having the, see, 3 and 4 are having the same magnitude. Okay, but their directions are opposite. So from 2 now, I have drawn 3 in this direction because it is negative, and from 3 again I came here, that is 4. Magnitude is same. So let us see here. This is the primary crank diagram. Okay, see here. This is your 3. 3 and 4 forces are in the same direction, but couple for 3 it is negative. This is positive direction, so negative is towards right. That's why we have drawn 3 like this. And 4, it is positive couple, so we have drawn again like this. Understood? Okay. So now you refer, this is 3 and 4. So from 2 to 3, 3 to 4, you again came here. Okay. Now you have drawn 4 to 5, 5 to 6. Both are positive. Okay. And according to the magnitude. So this is your crank diagram. See, this is your 5 and this is your 6, because both are positive couple, 0.045 and 0.075. Understood? So drawing these primary couple polygon, Where are you now? I have started from 0 or O here, and now I am here. So what type of couple you are getting? Polygon you are getting? Open polygon. I have started from here. So 0, 1, 2, 3, 4, 5, 6. Okay. So as it is an open polygon, primary couple is not balanced. So what is the magnitude of unbalanced couple? Unbalanced primary couple, UPC. Join these 6 to O. Okay, this is your unbalanced couple. This much couple is you have to provide to balance the primary couple. So joining this 6 to O will give you magnitude and direction of unbalanced couple. So join this one, measure the length of this vector CO, 6O. See here. So calculating primary unbalanced couple magnitude. So length of vector CO into whatever the scale you have taken into omega square, because we are not considering the couple mr omega square upon mr omega square into L. We have considered M, we have considered R, we have considered L, but we have not considered omega square. So whenever you calculate actual magnitude of unbalanced couple, you have to multiply by omega square. Okay. So this will give you unbalanced primary couple is 98 Newton meter. Okay. Now similarly drawing the secondary unbalanced couple. So secondary unbalanced polygon. Okay. We are here starting from 0. O. Pole. Okay. So now we have drawn 0 to 1, 1 to 2. Again, it is the same. It is negative. See here. Primary, secondary crank diagram. Now you have to refer secondary crank diagram to draw the secondary couple polygon. Okay. So 1 and 2, both are upward, both are negative. So you have to draw both the vector downward that we have drawn. Okay. Now let us draw which after this one we have drawn this one. 1 and 2. Okay. Then from 2 to again 3, 4. Okay. So 3 is positive. So sorry, 3 is negative. See, the couple of 3 is magnitude is negative. Okay. This is the direction. So this is positive direction. So negative is towards left incline. Okay. So 3 and 4 is positive like this. So again you have to repeat that line. So 3 and 4 are here. See, from 2 to 3 we have drawn, and again 3 to 4 we have drawn. So we came again at the same point. Okay. Then from 4 to 5, 5 to 6. Both are positive. Okay. So see, these are the direction. 5, 6. Both are positive. So 5 to 6, 4 to 5, 5 to 6. Okay. So we have started from point O. So O to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Your last point is here. Initial point is here. Okay. So how much is the unbalance? Join this point 6 to O. This length will give you magnitude of unbalanced secondary couple. So measure this length 6O, convert into original scale, multiply by omega square by n. See here it is difference because already see I will go take you to the original formula. See here. Purposely I have kept that one. What is the magnitude of primary unbalanced force and magnitude of secondary unbalanced force? Wait 1 second. In the recap only we have seen, see here, maximum value of primary unbalanced force is mr omega square and secondary force is mr omega square upon n. So what will be primary couple? Mr omega square into L. Secondary couple mr omega square upon n. Okay. So here to find out the magnitude of unbalanced secondary couple, we have multiplied by omega square and divided by n. Okay. So here, okay. So length of vector 6O, here it should be 6. 6O into scale into omega square upon n. Here it should be 6O, and that will be that we are getting 51 Newton meter. Okay. Now the primary couple unbalanced couple is there, secondary unbalanced couple is there. Can you balance it? Yes, definitely. How will you balance it? By just changing the firing order. Okay. When you change the firing order, force polygon will not change. That will remain same only. For any type of firing order, primary force and secondary force polygon will be same only. So you will be always getting forces balance, but couple polygon will be different because your directions only are different, no? Based on your firing order, you had drawn the primary and secondary crank diagram. So your primary and secondary crank diagram, these two diagrams will change when you change the firing order. Okay, so let us take the firing order. This one, by choosing a proper firing order, the engine can be completely balanced. Hence, choosing the firing order, see, this is trial and error method. You have to draw actually 1, 3, 2, 6, 4, 5. Okay, with this firing order, drawing primary and secondary crank diagrams and drawing primary and secondary couple polygons, we get closed polygons as shown in the following figure. See, so this is your crank diagram 1, 6, 4, 3, 2, 5, 1, 6, 2, 5, 4, 3. Okay, and this is your force polygon and this is your couple polygon. Okay, when we start from this point O here, okay, O to 1, 1 to 2, 2 to 3, 2 to 4, 4 to 3, 3 to 5, 5 to 6, every time you come here. So this is known as a closed polygon, though it is not exactly polygon. These are the lines, but as your initial point and final point is same, it is called as a closed polygon. Okay. Then secondary polygon starting from initial point O. Okay, O to 1, 1 to 2, 2 to 4, 4 to 3, 3 to 5, 5 to 6. Every time you come to the initial point. So this is also a closed polygon. So what is your conclusion? That if you change the firing order, so you have to select such a firing order that which will give you couple polygons balance or couples balance. Okay, so these are few firing order, some of the combinations which will give you completely balanced couples, both primary and secondary. Okay, these are the, so 1, 4, 2, 6, 3, 5, 1, 3, 2, 6, 4, 5, 1, 3, 5, 6, 4, 2, 1, 4, 5, 6, 3, 2. So if you adopt this firing order, your forces as well as couples will be balanced. Okay, understood? So now let us go to the next problem. Let us read the statement. A 4-stroke 5-cylinder inline engine. It's a 5-cylinder and 4-stroke has a firing order 1, 4, 5, 3, 2, 1. Sorry, 1, 4, 5. Okay, this is 1, 1. Okay, 1 is they are repeated. It is a 5-cylinder engine. 1, 4, 5, 3, 2. This you can write down in this way also because it is repeated. No, after 2 it will be again 1, 4, 5, 3, 2. The cylinder lines of cylinders are spaced at equal intervals of 150 mm. The reciprocating parts per cylinder have a mass of 1.5 kg. The piston stroke is 100 mm. Connecting rod length 175 mm. The engine rotates at 600 rpm. Discuss the primary and secondary balancing, the values of maximum unbalanced couples about the central plane, and position of crank from crank 1 from its IDC position at which these values occur. Okay, so let us write down the given data. Firing order is 14532. Distance between each two cylinder is 0.150. So 0.15 between each cylinder. Okay. Then mass is 1.5 kg. Stroke is 100 mm. So crank radius is 0.05 meter. L is 0.175 meter. So find out N, that is L upon R, that is 3.5. Then speed is 600 rpm. Find out omega, that is 2 pi n upon 60, that is 62.83 radian per second. And angle between each two crank is, as it is a 4-stroke engine, angle is not 360 but it is 720. 720 divided by 5 because it's a 5-cylinder engine is equal to 144. Okay, and we have to examine engine for, is there any unbalanced primary force, secondary force, is there any primary unbalanced couple, secondary unbalanced couple, that we have to examine. Okay, so which reference plane you will take? As I told you, it should maintain the symmetry. This is just a convenient, nothing else. Okay, our calculations are reduced. That's why we always take a reference plane in reciprocating engine problem, which will maintain the symmetry. So at plane number 3, We are assuming the reference plane. Okay, so let us draw the table now. This one. Okay, now what is the firing order? Please remember, this is your firing order now. 1 4 5 3 2. 1 4 5 3 2. So all columns are same now. You know, M R, then centrifugal force proportional to M into R, that is the product of these two columns. The distance of plane from reference plane, your reference plane is 3 0. Okay, so this distance is naturally 0, and remaining distances you write down. Then you take product of these two, that will give you couple, and these two cylinders are on the left hand side of the reference plane, so negative, remaining are positive. Okay, now how to write down this angle? Okay, so what is the angle between these any two crank? 144 for primary crank. Okay, and what is the sequence? 1 4 5 3 2. So let us, 1 is 0 degree, after that 4, 144 degree, after that 5, 144 plus 144 288, after that 3 hota na 3, so 288 plus 120, that is 432. Okay, so 432 minus 360 will give you 72 degree angle. After that, cylinder number 2, 432 plus 144, 576, minus 360 will give you 216. Understood? Now how to write down this second column? Last column, secondary crank angle, just make it double, don't think at all. Okay, so 0 degree, 576 into 2, 1152. That means minus 720 minus 360 will give you 72 degree angle. 432 into 2, 864 minus 720 will give you 144 degree angle. 144 into 2, 288. 288 into 2, 576 minus 360 will give you 216. Okay. Now what you have to draw? You have to draw couple polygon, primary crank diagram and secondary crank diagram. Okay, so we have assumed anti-clockwise direction here also. Similarly here also, both we must maintain the same. Okay, so cylinder number 1 is at 0 degree angle. Here also 0 degree angle. Okay, then what is the angle after that? 1, see, this is your 144 suppose. Any sequence you can select. So plane number 4, you draw at 144 degree. So plane number 4 here. Okay, from 1 to 4, 144. Okay, then 5 at 288. Okay, so from 1, it is 288. Here it is 5. Every reference we have taken from 1. Okay, so for 144, 288. Okay, then cylinder number 3, it is 72 degree from reference. So at 72 degree, 3 number. Then 2 number, that is 216 degree. Okay, so from 1 it is 216 here. This is cylinder number 2. Okay, so your sequence, whatever it may be, 1 3 4 2 5, you are getting at whatever the sequence you are getting, let it be. Okay, now you have to draw secondary crank diagram. Okay, starting from 1. So what is the angle? You can draw now, you can follow any sequence. Suppose 2 is at 72 degree from 0. So from here it is 72 degree. This is 2. Then 3 is at 144 degree. Okay, so from 1 it is 144 degree. Here it is 3. Then 4 is at 288 degree. Okay, so from 1 it is 288. Here it is 288, 4 number. And 5 number is 216 degree. Okay, so from 1 it is 216 is here. Okay, so the sequence for primary crank you are getting 1 3 4 2 5. Here it is 1 2 3 5 4. Whatever it is, you have to just draw the parallel lines using your roll and draw parallel line to these angular positions. To draw primary force polygon, you refer primary crank. To draw secondary force polygon, you draw secondary crank. Similarly for couple polygons also. Okay, so let us draw the force polygon now. What is the magnitude? P is proportional to M into R. Okay, so 0.075 Newton. Here it is. This column will give you force. Primary force. Secondary force will be divided by N. Okay, but it will also be same for all the ones. So MR upon N is 0.0214. You can take any scale because all the forces, primary forces are same. All the secondary forces are same in magnitude. Okay, so We have taken the scale, suppose for primary force 0.075, for secondary also suppose 0.075 Newton. 1 centimeter is equal to 0.075 Newton. Okay. So draw 1 centimeter, 1 centimeter starting from 0. Okay. So 0 to 1, 1 to 3, 3 to 4, 4 to 2, 2 to 5. You are getting pentagon, regular pentagon. Okay. And which sequence you can follow? It is better to follow this sequence. Just, okay. Means anti-clockwise direction like this. After from 1 to 3, 4 to 5. Like this here also. To draw the secondary force polygon, you follow the sequence 1, 2, 3, 4, 3, 5, 4. Okay. So you will be getting this polygon. Okay. 1, 2, 3, 4, 5 from here. 0 to 1, 1 to 2, 2 to 3, 3 to 5, 5 to 4. So you are getting close polygon. That means there is no primary for unbalanced primary force, no unbalanced secondary force. Okay. Now let us go to couple polygon. Okay. To draw this couple polygon, what you have to refer primary. Let us draw this primary couple polygon. Okay. So starting from O, initial point is O. First I have drawn O to 1. Why it is downward and what is the magnitude? So how to find out the magnitude? See, magnitude is given here in this table. Magnitude is these two are minus. This is 0 only. And these two are positive. So let us see crank number, plane number 1. Magnitude of the couple is 0.0225. It is negative. It is primary we are drawing. So what is the direction of primary? This one. Positive is upward, negative is downward. Okay. So that's why we have drawn this downward. 0 to 1. Taking suitable scale, of course. Okay. Then we have drawn 1 to 5. 5 is positive. And what's the direction? See here. This is your direction. 5 here. What's the magnitude of 5? This is 0.0225. Okay. So we have drawn 5. Then we have drawn which vector? See here. 5 to 2. It is negative. Okay. Plane number 2 is negative. So what's the positive direction? See here. 2 is here. This is positive direction. So negative is upward like this. And magnitude is this one. 0.01125. Okay. So we have drawn this vector from 5 to 2. Then draw 2 to 4. It is a positive. Your 4 direction is like this. Okay. So you have drawn in the same direction because it's a positive couple. Now you are here. We have started from O. Okay. So O to 1, 1 to 5, 5 to 2, 2 to 4. Okay. So 3 number is 0 only. That's why we are shown here. Don't see plane number 3 is having 0 couple. No, we are assume reference plane at this one. Okay. So that's why as it is 0 couple, that's why we have shown 3 there. You cannot show also. Okay. That means 0 couple. So 0 to 1, 1 to 5, 5 to 2, 2 to 4. You are here. So it's an open polygon you are getting. So what you have to do now to find out the unbalanced primary couple? Join 4 to O. Measure the length of this vector. Multiply by scale. Multiply by omega square. That will give you unbalanced primary couple. So length of a vector 4O into scale into omega square will give you 70 Newton meter. This is your unbalanced primary couple. Okay. Then draw the secondary unbalanced couple. See this one. Secondary unbalanced, secondary couple polygon. Okay. Starting from O. Now again O to 1. You know this is negative. Upward is positive. So downward is negative. So you have drawn O to 1. Now 1 to 5 is positive. Okay. So that's why we have drawn in this direction because you have to refer this now. Secondary crank diagram, this one. Okay. So this is your 5. And as I told you, you can take any sequence. Your final answer will remain same. Okay. So 5 is positive. Magnitude is this one. You have taken suitable again same scale. Okay. So and after that we have drawn 2. So 2 is negative. Positive is along outward direction. Negative is opposite. Okay. So after 5 we have drawn vector for 2. Okay. So this is Where is this one? 0 to 1 we had drawn, 1 to 5 we had drawn, then 5 to 2 we had drawn, and then 2 to 4. This is also positive. Okay, and now you are here. So initial point is O, final point is 4. So join 4O, that will give you unbalanced secondary couple. Okay, so how to find out magnitude? So length of vector 4O into scale into omega square upon n, because this is secondary couple. So secondary couple is secondary force into length. What is the secondary force? Mr omega square upon n. So upon n, this will give you CS is equal to 60 Newton meter. Okay. Now let us, the last question what is asked in this problem, what is the angle maximum value of unbalanced primary couple will occur when crank 1 rotates through 28 degree or this degree from its dead center. Okay, so crank number 1, see primary, here it is. What is the primary couple polygon? This one. Okay, so crank number 1, this is the angle. See, this is your 20, this is not 0 to 1 is this length. Okay, so if you rotate this by 28 degree, see here, 28 degree, okay, this is your unbalanced couple, no? The direction of unbalanced primary couple. So this angle is 28 degree. So when you rotate this crank at 28 degree angle, so the whole this crank diagram will rotate. Okay, so if you rotate this crank number 1 through 28 degree, it will be coming at parallel to UPC, unbalanced primary couple. Okay, because this is your direction we are getting. You understood, no? This is the direction we are getting. Okay, so crank number 1, which is vertically like this, if you rotate this and make it parallel to unbalanced primary couple, we will be getting the so maximum value of the unbalanced primary couple. Okay, so that was asked in the finally in the problem. Okay, so understood this one? Please solve this problem in your sketchbook or any plain paper or half imperial size drawing sheet if you are having, or in your notebook, choir book. But until and unless you solve this problem on the paper by taking your drawing instruments, okay, you will not be able to solve this problem in the examination. By reading or by explaining or by listening, you will understand everything. But when at the time in the examination, when you directly draw the problem, you will confuse like everything. Okay, so please have the practice to solve the problem on your own, in your notebook. All these core problem you have to solve. Okay, so here we finish the topic of reciprocating unbalance. In the next lecture, I am going to start unbalance of V engines, or unbalance of V engines, or you can say the V engine or W or whatever those engines are. That means not inline. Okay, those are having certain angle with each other, but not all the engines are not in the one line, but those are having the certain angle between each other, falling in the single plane. Okay, so thank you very much. I will stop here.